steel is one of the technological achievements of the innovation of ancient laborers, approximately 4,000 years ago. It was manufactured through the carburization of wrought iron. The carbon content of the resulting product may increase from 0.4% to 0.9% that could be tempered to produce a hard and sharp cutting edge necessary for many tools and weapons. It greatly hinged on the selection of raw materials, the delicate balance between reduction and oxidation reactions. Before the creation of modern steel, there was one type of steel contains up to 1 to 2% carbon, named Wootz steel. It was first manufactured through a unique method in the Indian subcontinent around 1000 BC. Alan Pendry is one of the archaeologists who successfully reproduced Wootz steel using the ancient method. Let's have a look at his experiment. The wrought iron is first placed in a crucible with wood chips, and the mixture is covered with leaves. The crucible is then sealed with clay and left to dry, leaving only a few small holes in the top of it. These crucibles are then placed in a large furnace and gradually heated with the aid of bellows to 1500 degrees Celsius for about 6 hours. In the gas carburizing process, the water in the leaves and wood is evaporated to produce large amounts of hydrogen. A crucible enriched with hydrocarbon gas can enhance the carburizing rate, which helps the wrought iron to draw carbon elements from the wood chips. The refining iron undergoes a chemical reaction with a high oxidizing synthetic slag at high temperature to produce liquid steel that sinks to the bottom of the crucible. During the melting process, workers typically use large quantity of carbon to ensure that the carburization is completed properly, as well as to maintain the ductility of Wootz steel. The excess carbon in the gaseous state is then removed by annealing, which is in the form of carbon dioxide. Once the melting is finished, and the crucible has gently cooled to the room temperature, the blacksmith breaks the crucible and removes the ingot. In addition to the unique smelting method, a mysterious forging technique keeps Wootz steel from suffering the effects of hot shortness. Archaeologists have resolved the secret of these ancient forging techniques through multiple experiments and conclude that, before forging, Indian blacksmiths had heat the ingots to 1100 to 1200 degrees Celsius for several hours. The decarburization treatment reduced the carbon and phosphorus content of the exterior of the ingot that eliminated the hot shortness of Wootz steel. As a hypereutectoid ferrocarbon alloy, Wootz steel became superplastic when heated to 800 to 850 degrees Celsius, so that it could be easily forged to sophisticated shapes. Due to the abundant knowledge reserve and superb steel-making skills of the blacksmiths, the physical properties of Wootz steel were better than most of the other metals in the past, which make it suitable to make lots of products, especially weapons. Therefore, the demand of Wootz steel steadily increased in India and started exporting to other countries. The opportunity that allowed Wootz steel became famous around the Middle East and Eurasia is that the Damascus blacksmiths mastered the forging technique after frequently importing Wootz ingots and produced Damascus swords with exquisite watering patterns and exceptional quality in the Middle Age. Therefore, Wootz steel is also known as Damascus steel. There are lots of tales about the manufacture process of the decorative design on the blades. One of them is that the blacksmith galloped on a horse, holding the red-hot sword with the sharp edge facing forward to generate watering patterns. The Damascus swords are sometimes confused with the forge-welded sword due to the similar patterns on the blades. In the regions where nobody mastered the techniques to produce Damascus sword, the blacksmiths alternating sheets of steel hammered together to produce decorative that were similar to the watering pattern. The Viking swords are one well-known example of these techniques. Archaeologists spent decades exploring the traditional process of manufacturing the watering patterns and finally figured it out. Based on the Pedrula's experiment, blades that are cooled slowly after forging by air circulation rather than crunching, tend to form a banded structure containing spherical carbide particles on a ferrite matrix, which can be seen on the blade as a pattern. Except the sword, the Indus Valley civilization also had many amazing wood steel products, such as the world-famous Delhi iron pillar. It weighed 6 tons and required Indian blacksmiths to produce at least 8 tons of uniformly composed steels and weld it together. From about 300 BC until the 18th century, India was one of the center of steel production. Its achievements in wood steel technology standing as a monument in the field of ferrous metallurgy.